After we decide which studies to include, we need to systematically collect the key information from each eligible study. This process is called data extraction. Data extraction means pulling out the important details from each paper in a structured and consistent way. The goal is to make sure we capture all the information needed to answer our research question. Data extraction means collecting information from each included study in a detailed and consistent way. We want to make sure that we are extracting the same types of information from every paper so that the results can be compared fairly. Another important point is that data extraction should be reflective of your research question. In most systematic reviews, this is guided by the PICO framework. Population: who were the participants? Intervention: what treatment or exposure was used? Control: what was the comparison group? And outcome: what outcomes were measured and reported? By focusing on extracting these elements, we ensure that the extracted data directly answer our research question. But I also would like to remind you that in addition to the PICO elements, it is also very helpful to collect basic information about each study, such as the author, the title, and the year of publication, and the research setting, country, and other information. This helps with the organization, referencing, and understanding the context of the evidence. Overall, data extraction is about being systematic, consistent, and focused so the final analysis is accurate and reliable. Now let's talk about how data extraction works in practice. First, before starting the full extraction process, it is important to pilot and calibrate the data extraction form. This means testing the form on a small number of studies to make sure the questions are clear, the categories make sense, and everyone is extracting data in the same way. Next, data extraction is usually done by two independent reviewers. Each reviewer extracts the data separately from the same studies. This helps reduce mistakes and personal bias. And finally, the reviewers compare their extracted data. If there are any disagreements, they discuss them and resolve the differences. And sometimes a third reviewer is involved if consensus cannot be reached. This slide shows what data extraction looks like in practice. In this table, we are focusing on two main areas: study characteristics and population. At the top, we have study characteristics. This includes the study ID, the country where the study was conducted, the duration of the study, the healthcare setting, and the type of funding. These details help us understand the context of the research and assess factors such as generalizability and potential conflicts of interest. Now we look at the study population. Here, the participants are smokers who used 5 or more cigarettes per day. We also record the total number of participants, how many were in each treatment group, their average age, the percentage of males and females. And we also extract baseline smoking behavior, such as the average number of cigarettes per day and the Ferguson score, which measures nicotine dependence. The key point here for data extraction is it needs to be structured and detailed. This slide shows the examples about interventions and eligible outcomes that could be extracted from eligible studies. In this case, for the extended duration therapy, participants received varenicline alone or combined with a nicotine patch for 24 weeks, and about 60% of them completed the treatment. In the standard duration therapy group, the same treatments were used, but only for 12 weeks, and again about 60% of participants completed the treatment. This kind of information helps us clearly understand what was done differently between the two groups. And we also extract what types of eligible outcomes were available in this study. And in the case study here, this trial reported 7-day point prevalence abstinence at month 12, prolonged abstinence at month 12, and these outcomes tell us how success was measured and when it was measured. Now let's look at how results are extracted in a systematic review. The types of data we extract depend on whether the outcome is binary or continuous. First, for binary outcomes with two possible states such as quit or not quit, we usually extract the number of events, the total number of participants in each group. For example, in this table here, we see how many participants achieved abstinence in the extended duration group and in the standard duration group, along with the total number in each group. Sometimes, studies also report effect size such as risk ratio or odds ratio and their confidence intervals, rather than the number of events and the number of total participants. These values can also be extracted directly if they are available. At the same time, for continuous outcomes that are measured on a scale such as quality of life or symptom scores, we usually extract the mean value and the standard deviations in each group and the sample size. Alternatively, sometimes studies report the difference between groups with a confidence interval, as shown in the quote here. For example, the study reports the mean difference in quality of life score between the two treatment groups. So in summary, binary outcomes, we will extract the number of events and total, or risk ratio and odds ratio. And if the confidence intervals are available, we will extract them too. And for continuous outcomes, we will extract the means, median values, and standard deviations in the quantile ranges, or mean differences between the intervention groups. Extracting these results in a structured way allows us to combine data across the studies and perform meta-analysis, which we will talk in the next video.